In this lesson, we're going to talk about adding and subtracting rational expressions. Adding and subtracting rational expressions. And before you watch this one, I would strongly recommend that you review the lesson on multiplying and dividing rational expressions, as well as identifying the domain and also simplifying rational expressions. So let's move on to this one. Now, rational expressions are, as we said, as said in other videos, rational expressions are like fractions. So when you're adding rational expressions, you want to add them in a similar approach as you would when you're adding fractions. So when we're adding two rational numbers, we make sure that the denominators are the same. So they must have common denominators. Similarly, when we're adding rational expressions, we add them with common denominators. Now, if the denominators are common, you just add or subtract the numerators as required or as necessary or as appropriate. And then we simplify the fraction from there. Similarly with adding and subtracting rational expressions. So as long as the denominators are the same, we just add or subtract the numerator and then simplify from there. Let's try with this example here. X over x squared minus 2x minus 3 minus 3 over x squared minus 2x minus 3. As you can see, the denominators are the same. So all we do is have the same denominator for both. X squared minus 2x minus 3 is a common denominator. And we just perform the operation in the numerator, x minus 3. Now, we need to simplify the expression. So what we're going to do is we're going to factor whatever can be factored, whether it's in the numerator or the denominator, or both. In this case, the numerator doesn't factor, so I put x minus 3. The denominator does factor to be x minus 3 times x plus 1. And as we see, there's a common denominator here, but I need to point out before we simplify a rational expression, remember we need to point out our domain restrictions. X is not allowed to be -1 nor 3. We need to bear that in mind. So when I simplify my fraction, I need to keep my same domain restriction. So my expression simplifies to be 1 over x plus 1 with the restriction that x cannot be -1 and it cannot be 3. And that's how you do, you simplify, you add or subtract rational expressions when the denominators are the same. Now, when the denominators are not the same, you need to get a common denominator. And you need to make sure you do that before you add or subtract. Now, the common denominator is often shortened as least common denominator. When we see LCD in this context, it means the least common multiple of the denominators. It's just shorthand. So when we say least common denominator, we really mean least common multiple of the denominators. Now, to find the least common multiple of the denominators, what we do is we factor all the denominators, and then we find the products of the common factors. So let's see how we would do that. So the LCD here, before we do that, we'll rewrite each expression in factored form. So we have 5 over x minus 2 times x plus 2. That's the first expression. Second expression, 1 over 2 times x plus 3. And then for the third expression, we have 6 over x plus 2 times x plus 3. Those are all factored. Now to find the least common multiple of the denominators, the LCD, here's how I would approach it. I go to the first set of parentheses and I write my factors down. X minus 2 times x plus 2. Then I go to my next factor. Is there 2 there multiplied in? No. So I'm going to multiply that into the expression. Is there x plus 3 already multiplied in? No. So I multiply that into the expression. Next step. Is there an x plus 2 there? Yes, there is. I don't need another one. If there were 2 of them here, I would need to put a square to make sure both are covered. But there's only 1 here, so I'm not worried about it. It's already covered. X plus 3 is also already covered. So my least common multiple of my denominators, my LCD, is 2 times x minus 2 times x plus 2 times x plus 3. 2 times x minus 2 times x plus 2 times x plus 3. And there we have it. Now, using that idea, we can now add or subtract rational expressions relatively easily. We first factor the denominators, identify the LCD, and then make sure that each expression is written with the same common denominator. And we do so by multiplying the numerator and denominator by an appropriate expression to ensure that the denominators are the same. Then we add or subtract as appropriate and simplify. So let's do this example as an illustration here. So first of all, we notice that the denominators are not the same. So since the denominators are not the same, we're going to have to get them to be the same. And so we're going to need to get a common denominator. Let's do that right now. So first, I'm going to rewrite the expression in factored form. 2x plus 3 over x minus 1 times x plus 2. That's how this one factors here. And I encourage you to check that. And this is 3 times x minus 1. So before we get our least common multiple of our denominators, we're going to point out that our domain restriction, x is not allowed to be -2 and it's not allowed to be 1, because that will make denominators equal to 0, and that's not allowed. Now, my least common multiple of my denominators, I start out with the x minus 1 times x plus 2. And then I go to the next fraction. There's expression. There's no 3 multiplied in, so I'm going to multiply that in. There's already an x minus 1, and that's covered. So my least common multiple of my denominators is 3 times x minus 1 times x plus 2. So what I'm going to do next is I'm going to rewrite the expression again, but now I'm going to make some modifications. So I'm writing out my factored form of my expression. And then this denominator is not the same as the LCD. What I will now do is multiply whatever factor is missing. I multiply to the numerator and denominator. This denominator is not the same as the LCD, so I'm going to multiply the missing factor, which is x plus 2, to both numerator and denominator. And then I'm going to proceed with the subtraction. So I have 3 times 2x plus 3 minus 5 times x plus 2 divided by what is now the common denominator, 3 times x minus 1 times x plus 2. And then I will proceed to simplify the expression and then make sure I put my domain restrictions, because I don't want to forget those. Because if I overlook those, I might have an issue when I'm needing to do more with this expression, as it may be to graph it or something like that. Now, we distribute the 3, we get 6x plus 9. We distribute the -5, we get -5x minus 10. Be careful, be aware of your positives and negatives. I will not distribute the denominator. That would be not a good idea, because it could cause more problems later on when we may need to do some other simplifying. So we'll leave it in factored form. Factored form is our friend, so we would need it to remain that way. Now, and let me just adjust it a bit so we have a little bit more space here. Now what I will then do is I will combine like terms. The denominator stays the same, 3 times x minus 1 times x plus 2, and then 6x minus 5x is x, and 9 minus 10 is -1. And what do you know? Both of these have there's an x minus 1 in the numerator. I can now cancel that, but I need to remember to put my domain restriction. So my answer now becomes 1 over 3 times x plus 2, but I did point out that x is not allowed to be, I'll write it down here, x is not allowed to be -2, and it's not allowed to be 1 just the same, because the cancellation would not have occurred otherwise. And that is my answer. I encourage you to review what I just did here with this exercise and then try it on your own to see if you can reproduce the same process. Let's go on to some more examples here. So in this case, we notice that the denominators are not the same, so we have to get them to be the same. Everything is multiplied, so I need to find the least common multiple of the denominators. See, I have a 5 here, and that's a 10. So the least common multiple of 5 and 10 is 10. I have an a squared in the first pair of parentheses, in this first denominator. That covers this a. And then I need a b as well. That covers this b. So that's the least common multiple of the denominators, the LCD. Now I take each fraction and I need to multiply by an appropriate expression or number to make the denominators the same. So in this case, I'm going to multiply the first expression by a 2 because I need it to be 10 a squared b. And I'm going to multiply the second expression by an a because I need it to be 10a squared b. A squared b. When I do that now, my result is 12 minus a over the quantity 10a squared b. And that's it. And we just remember that a and b are not allowed to be 0. All right. Let's move on to the next example. So in the next example, we have to do a little factoring. So we're going to first factor the expressions and we're going to simplify as much as possible. Let's not factor the top for now because this is a minus. We don't want to confuse it with a multiplication. But we will need to state our domain restrictions, so we'll remember that. So we have 4a minus 2 over 3 times a plus 4. And then minus a minus 2 over a plus 4. And of course, we then point out that a is not allowed to be negative 4. So we'll remember that. So the LCD will simply be 3 times a plus 4 because that's the first parentheses here, the first denominator here. And this a plus 4 is covered already. And now I need to only multiply the second fraction because the first fraction already has the common denominator. So the second fraction, we need that to be multiplied by the number 3. So I'm going to multiply the top and bottom by 3. And that will ensure that I have a common denominator. So when I do that now, I have 4a minus 2 minus 3 times a minus 2. And the common denominator will be 3 times a plus 4. I will now distribute the parentheses and simplify the expression. So I have 4a minus 2 and then minus 3a minus 6. Sorry, not minus 6, plus 6. Negative 3 times negative 2 is positive 6. And then the denominator is 3 times a plus 4. We continue. 4a minus 3a is a. Negative 2 plus 6 is 4. And so we realize that the numerator is as a common factor with the denominator. So we can now cancel a plus 4. When we do that, we end up with the fraction 1/3, but we still have to remember that our restriction is that a was never allowed to be negative 4, or else this cancellation would not have been possible. Now let's try this set of examples. In this case, we're going to rewrite the w plus 2 as a fraction. So we're going to rewrite it as over 1. And then we see that our domain restriction is that w is not allowed to be 2. And our least common denominator, least common multiple of our denominator, is just w minus 2. Same. So we're going to have w plus 2 over 1 plus 1 over w minus 2. To get the common denominator, we only need to get it for the first fraction, so we're going to multiply that by w plus 2. Sorry, by w minus 2. That's the common denominator. So we're multiplying by w minus 2, numerator and denominator. And then we're going to combine. So we have w minus 2 multiplied by w minus 2 plus 2, sorry, and then plus 1 over the common denominator, w minus 2. When I distribute that, I get w squared minus 4 because it's a product of conjugates. So the answer is a difference of squares. And the denominator is w minus 2. Simplifying now, our result is w squared minus 3 over w minus 2. And that cannot be simplified. W squared minus 3 is not a very palatable difference of squares. It's w minus square root 3 times w plus square root 3, and that doesn't cancel. So we can move on to the next example. And again, I recommend that you try these on your own and then check your answers in comparison to mine. So in this case, our domain restrictions are that a is not allowed to be 3 and a is not allowed to be negative 6. Those cannot be factored anymore, so we'll put them in parentheses. The least common multiple of the denominators is just a minus 3 from the first, and we multiply a plus 6 from the second because you cannot think about the 3 and the 6, you have to think of the whole expression. So now when I'm simplifying this, I multiply numerator and denominator by the appropriate expression that will make us have the same denominator. So I'm going to multiply this first expression by a plus 6. A plus 6. And this expression I will multiply by a minus 3, numerator and denominator. Effectively, we're multiplying by 1 because if you multiply by a number divided by itself, that's effectively multiplying by 1. And so we have a times a plus 6 minus 5 times a minus 3 is equal to a plus 6 times a minus 3. Now, please note that I didn't distribute right away because I have to be careful about that negative. If you don't skip steps, you can save yourself some trouble, but if you skip steps, you put yourself at risk. So I would recommend you show all your work and do not skip steps. So I distribute now and I get a squared plus 6a minus 5a plus 15. So a squared plus 6a, 6 times a, 6a minus 5a plus 15, and that's divided by a plus 6 and multiplied by a minus 3. So we continue, we're going to simplify the expression. We get a squared plus a plus 15. And that expression is actually prime. You can try to factor it, but you'll get stuck, and I recommend that you try it. And if you're familiar with the discriminant, if you check the discriminant of the top expression, that gives you a negative. If the discriminant is not a perfect square, a positive squared integer, or 0, then the expression does not factor. And of course, we will state our domain restriction. A is not equal to negative 6 nor 3. Let's move on to the next example. Now, in this example, we are going to be adding the two expressions here. And as usual, the first step is to factor the denominators. So we're going to factor the denominators of both fractions. We won't factor the numerator. So this is a difference of squares, x minus 6 multiplied by x plus 6. And then we're going to have minus, and we're going to factor the denominator of the other fraction, which is x. And let's just go step by step here. We need is a quadratic a trinomial with a leading coefficient of 1. We need two numbers that multiply to be 18 and add up to be 9. Those numbers are 3 and 6, both positive, because 3 times 6 is 18 and 3 plus 6 is 9. Now we can see we're going to stipulate that x is not allowed to be either 6 or -6. Let me put the negative first. And as well, x is not allowed to be -3. We already said it's not going to be -6. So those are the three domain restrictions. Then for the least common denominator, the least common multiple of the denominators, what we do is we write the factored denominator of the first fraction. And then we go to the next denominator, any factor that is not already represented to the correct number exponent, then we'll multiply it in. In this case, x plus 3 is not already in the least common denominator, but x plus 6 is already there. So our LCD is x minus 3, x minus 6, x plus 6, and times x plus 3. And now we go to the next step, which is we're going to need the denominators to be both the same. So I'm going to put the numerator in parentheses, and I'm going to multiply each fraction by an appropriate factor, numerator and denominator, so that we get the same denominator for the fractions. So for this first fraction here, I'm going to, since we need an x plus 3, I'm going to multiply x plus 3 to the numerator and the denominator. And for this next fraction, we need an x minus 6 to get the denominators to be the same as the least common multiple of the denominators, the LCD. So I'm multiplying both sides, numerator and denominator, by x minus 6. Now we move on to the next step, which, now that the denominators are exactly the same, I'll just write it as one denominator, x plus 3, x minus 6, x plus 6. It doesn't matter what order I have write the factors in because of the commutative property of multiplication. Now I'm going to distribute the x plus 3 multiplied by the x plus 2, and I'm going to distribute that negative x to the x minus 6. So we're going to do a little distributive property here for those, and we're going to FOIL here. I won't show that here because of the space. So I'm going to write my denominator again. We're not going to distribute the denominator. Do not distribute the denominator. You want to factor the denominator and leave it in a factored form. All right, so we have x plus 3 multiplied by x minus 6 multiplied by x plus 6. And now the numerator here is x times x is x squared. X times 2 is 2x. And then another x, 3 times x is 3x, 2x plus 3x is 5x. And then 3 times 2 is 6. And then negative x times x is negative x squared. And negative x times negative 6 is positive 6x. Then I will combine like terms. An x squared plus a negative x squared is 0. And then 5x plus 6x gives us 11x. So we're going to go down here and write 5x plus 6x is 11x. And then there's a plus 6. And then our denominator is x plus 3 multiplied by x minus 6 multiplied by x plus 6. And that is our result from the addition subtraction of those two fractions. Of course, remember to put our denominator x not equal to -6, -3, and +6. That's our domain restrictions. And there we have it. Let's go on to the next example here. In this case, I want you to notice something here. The denominator here is 5 minus n, and the other denominator is n minus 5. And you should remember, and I'll write as a little note here, you should remember that when you have a situation like that, they are actually the negatives of each other. 5 minus n is actually the negative of n minus 5. And if we recognize that, it will make our lives actually much easier. because then the denominators can be made to be the same without having to do much work. I can rewrite 5 minus n then as the negative of n minus 5. The negative of n minus 5. And what I can do with that is I can then just multiply the numerator and denominator by -1, or in short, we say we move the negative to the top. That when you have a negative fraction, either the numerator is negative or the denominator is negative, not both. So if the bottom is negative, you can always actually move it to the top. So I'm moving the negative to the top, and I have n minus 5 as the denominator here. And if you notice, that now gives us the same denominator for both fractions, which means we don't have to find any least common multiple of denominators, because there's just that denominator. We also remember that our domain restriction is that the denominator is not allowed to be 5. The n, sorry, is not allowed to be 5. The denominator is not allowed to be 0. And so we find all the values of n that makes the denominator equal to 0 and make sure n is not equal to that. Now when we combine the fractions, we get negative n plus 2n minus 5 over n minus 5. I combine like terms here, and I have negative n plus 2n is n, and we have minus 5 over again n minus 5. So we're dividing something by itself. And if we're dividing something by itself, then that result will give us 1. So this results in the number 1, but as long as n is not equal to 5. If n is equal to 5, it gives no answer at all. It's undefined. The expression is undefined. But otherwise, the expression simplifies to be 1. So that one turned out to be a little simpler than we expected it to be. But we still have to bear in mind that there are a number of nuances that we have to pay attention to. And with those nuances, we have to make sure that we're not overlooking certain things, such as identifying negatives of a binomial expression. But it simply means here about a 5 minus n and an n minus 5 are just negatives of each other. And so now, let's move on to the next example. And we're getting a little bit more complicated as we go along. So in this case, and please be careful about confusing your z's and your 2's, write them clearly. We're going to factor as before. In this case, I'll see that this factors to be 2z plus 3, sorry, 2z minus 3, and another 2z minus 3, so it's squared. And I'm going to leave you to check that by doing it step by step. And I put my slash through my z's to make them distinct from a 2. I factor the z here, and I have 2z minus 3 in parentheses. So my domain restriction is that z is not allowed to be 3 over 2. And my least common denominator is I have a 2z minus 3 squared here. I go over here, I'm missing a z, I factored a z, and I have an additional 2z. I have a 2z minus 3, which is already covered by this 2z minus 3 squared. So that's my common denominator. And so now I can proceed. I'm going to rewrite my expression and multiply in my common denominator, my factors to get a common denominator. 2z minus 3 squared minus, I'm going to put a parentheses around z plus 1 over z times 2z minus 3. And so now this one I just need a z to be multiplied in, so I'll just multiply z into those. And this one I need an additional 2z minus 3, so I can get a square in the denominator. Multiply to the numerator and the denominator. And then we combine the numerator and denominator. 2z minus 3 minus, and when we're distributing here, we're going to be distributing the negative afterwards. So I'm going to put this in parentheses. Z times 2z is 2z squared. Z times negative 3 is negative 3z plus 1 times 2z is, which is plus 2z is negative z. And then 1 times negative 3 is negative 3. And then the denominator will keep as z multiplied by 2z minus 3 squared. Now let's continue. We see here that if we distribute the numerator, we distribute the negative, we get negative 2z squared. We have 2z minus 2z squared plus z plus 1 plus 3. And then the denominator will keep as z times 2z minus 3 squared. Now 2z plus z is 3z. So we have a negative 2z plus 3z plus 3. So let's take a look at this to see if it can be factored. If I multiply this, I get two numbers. Negative 2 times 3 is negative 6. Two numbers that would multiply to be negative 6 and add to be 3. And we're trying to see if there's any such number, and none is coming to mind, so it indicates there's no factoring. And if you find the discriminant, 3 squared minus 4 times negative 2 times 3. 4 times negative 2 times 3 is 24. And then plus another, that's negative 24. And 9 minus negative 24 is 33. And that's not a perfect square, so this doesn't factor. So we're stuck here. We're going to have to leave the expression as it is. And so our expression, the result is as written, with the stipulation that z is not equal to 3/2. Oh, and also z can't be equal to 0. I neglected to put that down. So z cannot be equal to 0, and z cannot be equal to 3/2. So once again, you need to make sure you check your domain restrictions to ensure that you are I left out the z squared, sorry. To ensure that you're not including values that are not supposed to be included. It's very important to take careful process here. Now let's move on to the next example. Let's see what we can do with this one. So with this one here, I'm going to do a little trick to help us with a little factoring. This is 9 minus x squared, and this is not going to give us 3 minus x. So what I am going to do is I'm going to do a little rearranging. I'm going to write that as negative of x squared minus 9. And I'm going to factor this in a minute. But what I'm also going to do is I'm going to move the negative to the numerator. So you end up with negative 5 over x squared minus 9. And then we're going to factor. So we have negative 5 over x minus 3 times x plus 3. And then minus 4 over x plus 1 times x plus 3. And as you can see, both of them has an x plus 3, but I prefer to have a positive leading variable than a negative leading variable. So our domain restriction is that x is not allowed to be negative 3, negative 1, or positive 3. And our least common multiple of our denominators, let's write it underneath. Least common multiple of our denominators, or LCD, is x minus 3 times x plus 3 from the first denominator. And then x plus 1 wasn't the original, so I'll multiply that in. And there was already x plus 3, so we're covered. And so now, what we're going to do is multiply both fractions by an appropriate number that will allow us to have a common denominator, an appropriate expression, sorry. So x minus 3 times x plus 3, leave some space for the multiplication. 4 over x plus 1 times x plus 3. And we are going to multiply this expression by x plus 1, numerator and denominator. And we'll multiply numerator and denominator here by x minus 3. And then we'll combine we'll combine the numerator and denominator and see what we can do from there. So we have negative 5 times x plus 1 minus 4 times x minus 3 divided by x plus 3, x minus 3, and x plus 1 times x plus 1. So we distribute the parentheses, we get negative 5x minus 5 minus 4x plus 3. So negative 5x minus 5, negative 4x plus 12, I said plus 3. So the denominator is x plus 3 multiplied by x minus 3 multiplied by x plus 1. So negative 5x minus 4x is negative 9x. And negative 5 plus 12 is 7. So this doesn't factor. So we leave the denominator as it is and the numerator as it is, with our restriction that x is not allowed to be negative 1, positive, or negative 3. All right, let's move on. And this example, we're doing a systematic number of examples. I believe this is the last example actually. And then we can move on to the next concept, which will be covered in another video. So we have k over k plus 7 minus 2 over k squared plus 6k minus 7 plus 4k minus 1. As usual, factor what can be factored in the denominator, what can be factored we put in parentheses. And then, of course, our domain restrictions. K is not allowed to be negative 7 nor 1. Please come and multiply the denominators. K plus 7 times k minus 1 and then we move on. So we have k over k plus 7 minus 2 over k plus 7 times k plus 1, k minus 1, and then plus 4k over k minus 1. From the least common multiple of the denominators, the LCD, we realize that this one is missing a k minus 1 in the denominator, so we multiply it in the numerator and denominator. This second fraction isn't missing anything, so we don't need to do anything with that. We don't need to adjust it, and this one is missing a k plus 7, so we'll multiply it in the numerator and denominator. And then we're going to combine the fractions. So we have k times k minus 1 over, minus 2 plus 4k times k plus 7. And then we will have the common denominator k plus 7, k minus 1. Now if we distribute, we have k squared minus k minus 2 plus 4k squared plus 28k. When we distribute the parentheses, and let me just do a quick little indication of what we're doing here. The denominator is k plus 7 times k minus 1. And we're going to continue now up here. So k squared plus 4k squared is 5k squared. Negative k plus 28k is 27k. And negative 2 has nothing else there, so we have minus 2. Okay, now we can try to factor that. but we'll get stuck because you can't find two numbers that multiply to be negative 10 and add up to be positive 27. And it's not going to work. So we're just going to leave it as that. And the domain restriction is k is not allowed to be negative 7 nor 1. All right, so just got a preview of what the next topic will be. But for now, we've covered in this video adding and subtracting rational expressions. The next lesson will be on simplifying complex fractions. The previous lesson was about multiplying and dividing rational expressions. Please make sure you review those lessons. You can see the other videos in the listing and on YouTube. All the best, and remember to study, practice, and prepare.